You know, inside every single gadget we use, there's a specialized brain, a custom chip that makes it all tick. But trying to understand them can feel like drowning in alphabet soup. ASIC, FPGA, SoC, what does it all mean? Well, they're all custom chips, but they are worlds apart in how they work. So today, we're going to break it all down and figure out how these little silicon brains power everything from your phone to a rover on Mars.
All right, so let me ask you something. What could a device that fits in your pocket possibly have in common with a multi-million-dollar robot exploring another planet? I mean, really? The answer is actually pretty fundamental.
The answer? They both have these super specialized brains, custom computer chips built for very specific jobs. But here's the catch. The kind of brain you need to stream TikToks is very different from the one you need to navigate the rocky surface of Mars. And that's the key. Not all of these silicon brains are created equal.
So let's dive into the first type. The most specialized of them all, let's call it the custom-built brain. This brings us to the first major player in our silicon showdown.
This is the ASIC, which stands for Application-Specific Integrated Circuit. And honestly, the name really tells you everything you need to know. This is a chip that is designed from the ground up with painstaking detail to do one thing and one thing only.
So what's the deal with an ASIC? Well, it's typically designed by one company for one very specific product. And because it's so specialized, it gets you absolutely incredible performance and SIPs power. But, and this is a huge but, its function is literally frozen in silicone. Once that chip is made, that's it. It can never, ever be changed.
The best way to think about an ASIC is like a custom printed book. Designing it and setting up the massive, complex printing press costs a fortune. But once you've done that, printing millions of individual copies is super cheap. And just like that book, once the text is printed, it's permanent. No typos, no updates, no new chapters.
Okay, that's great. But what if you need flexibility? What if your design might change, or you need to add new features later on? Well, that brings us to a completely different philosophy, something we can call a reprogrammable canvas.
And for that, meet the FPGA, or Field Programmable Gate Array. Now, the keywords to remember here are configured by the user after manufacturing. An FPGA is basically a blank slate of silicon. You buy it off the shelf, and you get to program it to become whatever chip you need it to be.
So if the ASIC is our permanently printed book, the FPGA is its complete opposite. It's a high-tech whiteboard. You can draw a complex circuit on it, see how it works, and if you want to change it or add a feature, you just wipe it clean and draw a new one. It's an incredible superpower.
So how does this magical whiteboard actually work? Well, it really comes down to three main parts. First, you have thousands of tiny configurable logic blocks. Think of them as digital Lego bricks. Second, you have this massive flexible web of wires that can connect those bricks in any pattern you can dream up. And third, you have the I/O blocks to talk to the rest of the world. By telling the chip which bricks to connect to which wires, you can build pretty much any digital circuit you can imagine. Okay, so let's put these two head-to-head. Our FPGA whiteboard gets you to market way faster, and it gives you total flexibility to change things. The ASIC book, on the other hand, is totally rigid and takes forever to design. So why bother? Because in exchange for being inflexible, ASICs give you the absolute fastest speeds, and they are way, way cheaper per chip, if you're making millions of them.
All right, so we've got the book and the whiteboard. Makes sense, right? But what about those other letters floating around in our alphabet soup? Let's quickly clear up the other acronyms that cause all the confusion.
First up, the ASSP, or Application Specific Standard Part. The easiest way to think of this is as an ASIC that's, well, not a secret. Instead of being custom for one company's product, it's a specialized chip that's sold on the open market for anyone to use. You know, a standard USB chip in your computer? That's a perfect example of an ASSP. And next, we have the famous SoC, or System on Chip. Now, the one thing that makes something an SoC is super simple. It has a processor core on it. We're talking about a real CPU, like the kind in your computer, but shrunk down and integrated onto a single piece of silicon with its memory, I/O, and the whole shebang. It's a complete system on a single chip. And here is the simple rule that ties this all together. If you design a custom chip, whether it's an ASIC for your own product or an ASSP to sell to everyone, and you put a processor core on it, then, by definition, it's also an SoC. An SoC isn't really a separate category, it's just a type of custom chip that's complex enough to have its own brain. That's it. Okay, feeling good? Got it all sorted out? Well, not so fast.
because just when we get comfortable with these nice, neat categories, technology goes and changes the rules. The lines we just drew are starting to get really, really blurry.
You see, the FPGA has been evolving like crazy. It's not just a blank canvas of simple logic anymore. Modern FPGAs come packed with specialized hardware for math, huge chunks of memory, super fast data connections, and, yep, you guessed it, they now have full-blown hardwired processor cores built right into the silicon.
And this mashup has caused a real identity crisis in the industry. As the well-known technologist Max Maxfield said, the old definitions just don't feel right anymore. For years, engineers have equated the term SoC with a custom-designed ASIC. So when a programmable chip starts acting like one, it gets confusing, even for the experts.
Which, of course, has led to a whole new mess of confusing names. You'll hear companies call these new hybrid chips SoC FPGAs or programmable SoCs. The bottom line is our high-tech whiteboard now comes with a pre-printed computer brain on it, and those clear lines we drew earlier, they have officially been blurred into oblivion.
So with all this confusion, how in the world does anyone actually choose the right chip for their project? Well, thankfully, it all still comes down to a few really key questions you have to ask yourself.
It really all boils down to those original trade-offs. Do you need the absolute fastest performance and the lowest possible power for a product you're going to make millions of? Is the design completely locked in? Then you need an ASIC, hands down. But if you need to get your product out the door fast, if you know your design will need updates, or if you're only making a few thousand units, then the flexibility of an FPGA is your only real choice.
And that really brings us to the big, final question, doesn't it? We're watching these two worlds, the permanent, frozen world of custom silicon and the flexible, programmable world of FPGAs, collide and merge into these incredible new hybrid chips. So you have to wonder, as we move forward, will those lines blur so much that the future isn't about choosing one or the other, but about finding the perfect blend of custom and programmable for every single task? The alphabet soup, it seems, is only just starting to get interesting.